All right, welcome back, everybody. Today we're going to be talking about 4.8a, which is writing equations of sine and cosine functions. Our objective today is that we're going to be able to write the equations of a sine and cosine function if we are given a graph. Now, you may recall that this is the exact opposite of what we've been spending all of our time on recently. Prior to spring break, we were being given the equation and we were being asked to produce the graph. Now it's going to flip. We're going to be given the graph and asked to produce the equation. So let's take a look here. Right off the bat, let's just do a quick warm up. So up front, we have four graphs, A, B, C, and D, and we want to determine which equation matches up with them. Now, remember, the biggest way to identify the difference between a sine and a cosine graph is where your graph starts on the midline. Cosine graphs will always start either up in the air or down below your midline. So we know right away that this one will be a cosine, whereas sine graphs always start at the midline. So this would be a sine function. This would also be a sine function, and this would also be a cosine function, right? Because it's starting below. So it's all about where it's starting in regard to the midline. Now, when we see that we have a graph a cosine graph that goes down, this is the normal behavior for a cosine graph is for it to start up in the air. If it's starting up in the air, that means your A value is positive. So this is a positive cosine graph. And for sine, if sine starting at your midpoint, if your graph goes up, like this one did, it trended upwards, that tells us that we have a positive sine function. So for C over here, this would also be another positive sine function. And then lastly, for this bottom cosine one, since our cosine point is starting below the midline, that tells us that this will be a negative cosine function. So we can obviously see our choices down there and we can start to piece this together. The other thing that we have to play with is we do know about amplitude a little bit. This one is going 3 up above the midline and 3 below the midline, so we know that this must have a 3 as its amplitude, and that's always the first value. Same with our sine function over here. We are 3 above and 3 below, which means we have an amplitude of 3. This one, for part C, only has an amplitude of 1. It's only going 1 above and 1 below the midline, so we can slide a 1 in there. And for our cosine one over here, this one again has an amplitude of 3, but it's starting from that negative position. So we're going to have a negative 3 amplitude. So it looks like actually right off the bat here we can match these up. This one, 5, has to go with D, and we can already see how we put that stuff together for ourselves. 3, a positive 3 sine, this is 1. That has to go with B up here, right? And we're already matching those pieces of information up. We have another sine over here of 3x. So hold on. So just looking at this, this would be 1 sine, which is good, only 1 with 1 sine. So this must mean that 4 comes over here. I'm sorry, 6 comes over there. And it looks like for the first one, 3 cosine positive, this one must go to 2. Now, one thing to know about this, only one of these really actually had, hold on, did we get that right? Did we get that right? Actually, I don't believe this one is correct. Now, let me tell you why I don't believe that one's correct. Now, hold on. This one, our midline was up 3 in the air here. So there should have been a 3 that was added to it somewhere. Definitely did not grab the right one. Hold on. This one matches up with this one. Now, we can see right down there that that 3 plus sine of x is not in the normal spot we normally look for it, but it does still mean the same thing. It still has the same effect on our graph. So let's go a little bit further. So a couple pieces to remember. So first off, this 35, this is our A value. This 3 is our B value. This is our C value, and this is our D value. And each of those values in these functions have their own specific role. A is our amplitude. B is normally dealing with our period. It's not exactly our period, but it deals with our period, so that's how I refer to it. C is any phase shift that we have going on. And D is going to be where our midline is located. Right, so each of those is always going to play its role, and the general form of any one of these functions, you can always change out whether it's sine or cosine, will look like this. Right, so what we're going to do when we write these functions today is we're probably going to write them more in that general form, and if there's pieces that we don't have, we're just going to include zeros at those spots. Now, here are general steps to writing the equation to a sine or a cosine function. Step number 1 is going to be to find the midline. Step number 2 is to figure out our amplitude or our height. Step number 3 is to determine if we have any phase shifts, and if so, what is it? Step number 4 is to determine the period to figure out our b value. And then last but not least, we are going to write the equation in this form. Again, we're going to have all of those pieces there. So if we're missing one of them, we will include a 0 instead of just leaving it off. So here's our first problem. Now, right up top, they're telling us they're going to want us to write this as a cosine function, which is fine. So coming over here, we can already see that this is set up like a cosine function because we have a starting point that is sitting up here in the air, just like it should. Now, in order to determine our midline, sometimes we can just eyeball it. Other times we have to be a little bit more systematic to figure out where it is. So our midline in this situation is 1. So that means we had a vertical shift of 1. We're up 1 from where we were before. This vertical shift, I think you could also really just think about this as your midline. Now, that's going to be the first part I look for because after you know what your midline is, then you can figure out your amplitude. We can see that our amplitude here is 2, so we can come with 2 over here. To identify our period, we're looking for where this repeats. So if we start at a high point here, another high point is where our period will end. So over here, we can see that we have a period of 2 pi. So we can have 2 pi right here. And then this one actually did not have a phase shift, right? This one started right where we wanted it to. Every sine or cosine function could also be written as a sine, and that's where these phase shifts are going to kind of come in. So this one we can say none for this particular situation. And then for our function, this is where we got to actually sit there and think a little bit. So for our function, remember our general form will be a, since we're writing a cosine, of b parenthesis x minus c plus d. Now, we can start filling in these pieces right away. We know that this is our normal cosine function and that our amplitude is positive on this because of the fact we're starting up in the air. So we're going to have 2 times the cosine. Now, b is the part we don't know much about right now. So I'm going to just put x. I'm going to leave a little space for b. We'll come back to that. Now, since we did not have a phase shift in this problem, we're going to be able to say plus 0 or minus 0. Either way is okay. And then our midline in this situation was 1, so we're going to come over here and say plus 1. That means everything was relatively straightforward for us to find except for our b value. Now, the way you're going to calculate your b value is what you should realize is that to figure out our period normally, we would take 2 pi and we divided it by whatever our b value was. And this gave us our period. Now, in this particular situation, we know what our period is. Our period, since we have the graph already, we can just look at it and tell. So we found that our period was actually equal to 2 pi. Now, in this situation, knowing what our period is doesn't necessarily tell us what our b value is. So what we do is we set up this mini equation over here and we actually solve this. Now, anytime you have a situation like this, there is a switch that you can automatically make to put 2 pi on the bottom here and move b over to here. So doing that, we would get 2 pi over 2 pi, which is equal to b. And then, of course, anything divided by itself is just equal to 1, which is what our b value has to be. So we're going to use this method to actually calculate what our b value is. So our b value in this problem is 1, which means this is the function of 2 cosine 1 times quantity x plus 0 plus 1. Let's take a look at another problem. Here's another one. Now this one we're being asked to write as a sine function. As you can see right away, this is already looking somewhat like a cosine function because of where that starting point is. So what we're going to do is we're actually going to shift our function in order to make this look, in order to write this as a sine function. So again, we're going to go through the same process here. So right off the bat, we're going to find our midline. So our midline here is 1. And we're going to sit there and calculate our amplitude, which in this case looks to be 2. Now this is the same graph we were working with before. Even though I want to write this as a sine function, I can still find the same period from looking at the cosine. That part's not going to change. So if I look at the 2 high points together, remember you can calculate the period using any 2 like points essentially on those graphs once you've completed a full circle. But our period here is still going to be 2 pi. This one will have a phase shift because the phase shift is what's going to allow us to write this as a cosine function, or I'm sorry, as a sine function. Now, what I want to do here, let's actually try something. I don't know if this will work or not. If I actually come over here and just trace this out for a second, this might help us see the phase shift that needs to happen. This function essentially needs to move in order to be written as a sine. As a sine function, we could either have it moved over here, right? And what we're looking for is we want our graph to be crossing kind of at that y-axis right there. So this would be one way we could write it as a sine function. Another way we could have written it as a sine function is if I would have taken the whole graph and actually scooted it over this way. Since we do still cross at the midline on our y-axis there, this would still be considered a sine function. Now, I think what I'm going to do is I'm going to write it kind of both ways so that we can see the similarities between it. So first, let's move it over to the right. So it looks like I'm moving it over, essentially, if I take, let's try this. If I slide it over 1, I'm moving over 1 tick mark. From this tick mark, I'm moving that point over to there. Now, what we do know is that that tick mark is representative of a negative pi over 2. So we moved, in this situation, our graph over to the right, pi over 2. So if I go with this and I go to the right, pi over 2, how would that look for our equation? So for our equation, we would come over here and we would say, well, my amplitude is 2. So I have 2 times the sine. Now again, that's a positive 2 since our graph is going up like it should in any sine function right there. So 2 times the sine. Again, our b value becomes the problem, so we're just going to leave that as a blank for a minute. And then we're going to have x. Now, if I move this to the right, pi over 2, then as we know, we need to subtract pi over 2 inside here. So we're going to subtract pi over 2, and then our vertical shift or our midline will still be 1. Now, to calculate our b value, again, you take your period, you put it over b, or I'm sorry, you take 2 pi, you set it over b, and you set that equal to your period. Now we swap those out, so we get 2 pi over 2 pi. This one's boring, just like the last one, because they're the same graph at this point. You get 1 is equal to b. So I can put a 1 right here. Now this would be one way we could write this function. If I actually go back, though, if we instead had shifted this function back this way, we can still write this as a trig function of sine as well. Now, in this situation, our graph is heading down after that midpoint, which means our amplitude is going to switch to negative. So I'll have negative sine. Our b value actually isn't going to change here. And the only other part that is going to change is instead of being a minus pi over 2, now we've shifted it to the left pi over 2, which is in essence, sorry, my light turned off, in essence is going to be to the left pi over 2, so we're just going to say plus pi over 2. These two equations are actually both correct. Both of these are correct. So it's important to realize the similarities and differences between them. Now, this graph was the exact same as this graph. So another piece you should take away from this is that every graph can be written as either a cosine or a sine function. And sometimes there's multiple representations of these. Let's do another one. So here's another one. This is a cosine. Now, right now, we can see that our graph is set up like a sine graph would be. So we're going to have to sit there and shift this whole graph back so that that top point lines up top. So there will be a phase shift that needs to happen. Since this is pi over 4 right there, we're going to need to shift our graph left pi over 4 in order to complete this. So our phase shift, we're going to be going left pi over 4. Now, it looks like our midline here is at 0, so we are going to say 0. Our period here, again, it doesn't matter where you measure from. If you start at the center, it looks like you have another spot where the cycle would have happened, and that's over here at pi, so our period is going to be pi. And it looks like we are going 5 above the midline and 5 below, so that's our amplitude. So if we wanted to write this as a cosine function, maybe I'll trace this over there again. If that was helpful, that would be great. So we're going to just move our function. We're going to pretend we were able to move it with that phase shift. So there it is. So now we're lined up like this, which is how we like a normal cosine function to look. The period doesn't change, though, when we move that phase over. So coming over there, since we're starting up top, we know our a value will be positive. So this will be 5 times the cosine of, let's leave our b blank for a minute. We did move our graph left, pi over 4. So to move anything left, we're going to take our x value, and we are going to be adding pi over 4. And our midline is 0, so I'm going to say plus 0. Again, to calculate your b value, take 2 pi over b and set that equal to our period, which was pi. Switch these two pieces, you get 2 pi over pi is equal to b. Our pi's cancel out, which means our b is equal to 2, making this our final answer. Let's take a look at another one. So here's another one. This is a sine function. Now this one is set up like a sine function should be, so there's going to be no phase shift since our starting point is where we expected it. So we can say none right here. It looks like our midline is at 0 again, and we have an amplitude in this situation. I think this is a negative 1/2 and a positive 1/2. So we're just going to say that we are going up to, or we have an amplitude of 1/2. Now our period in this situation, where did we repeat? It looks like we did at 2 pi over 5, so that will be our period. We're super close to being done with this. Now, one thing to notice is that our sine function is trending down starting from that midpoint. That means our a value here is going to be negative. So we will have a negative 1/2. We're writing this as a sine of sine. Let's leave our b value blank for a minute. There was no phase shift, so we're going to say x plus 0 or x minus 0. Either are fine. And then our midline was 0, so I'm going to say 0 over here. To calculate our b value, let's take our period, which is 2 pi over 5. All of that's going to get divided by b. I'm so wrong. Hold on. Take 2 pi over b and set that equal to your period. Now, but you can solve this a variety of different ways, but in this particular, there's a trick you can utilize. If this is 2 pi over something is equal to 2 pi over 5, the only way for this to be true is if b actually equals 5. Now, if you don't notice that trick, then you would have tried to solve it by switching, and that's fine too. Here's how you would have done that. So coming over here, you're going to basically move this to the bottom. You're going to move b over here. So you're going to have 2 pi over 2 pi over 5. So we're going to rewrite this at this point as 2 pi over 1 over 2 pi over 5, and that's all, of course, equal to b. So we have a dividing problem, so if I take my 2 pi over 1, divide that by 2 pi over 5, what that's going to mean for us, I'm going to work this way so I don't go into my face. I got 2 pi over 1 times 5 over 2 pi. My 2 pi's cancel each other off, and I'm just left with 5, right? So a lot of different ways to solve that, but that's what your b value is. Making this our final answer. Negative 1/2 sine of 5 times x plus 0 plus 0. Here's another one for us. This one is a sine function. So coming over here, let's maybe clean up our graph. So this is 1, 2, 3, 4. It looks like we're hitting a high point of 5. Again, we're writing this as a sine. Currently, it's set up as a cosine, so there's going to have to be a phase shift. What we're really going to probably do is move this point essentially back to our y-axis right there so that it can be written as a sine. So we're going to need to shift our graph. It looks like this is 3 pi over 2, or those graphs didn't quite copy nicely. So we're going to be going left, 3 pi over 2. As you do that, again, I'm just going to copy over the top of this so we can physically move it and see. We're going to move it, so here it moves, just like we kind of thought it would. Now, again, in order to check your period, actually before we move it, let's do our period before we move it. So our period, if you start at 0, it looks like it repeats over here at 6 pi. So there that is. Now when we move it, the period doesn't change, so it's still going to be 6 pi is the period. But now we can kind of see what's going on a little bit more. Our amplitude here, it looks like we're going 2 above the midline, so that's going to be 2 right there. A vertical shift, we had our midline at 3, so we can have a 3 right there. Now remember, a normal sine function should trend upwards to start. If you're not trending upwards right away, that means your amplitude is negative. Since this one would start here and work downwards as we go along, that means our a value is going to be negative. So we're going to have a negative 2. Remember, that's the amplitude that we found earlier. We're writing it as a sine function, so sine. We're going to leave our b value off, so this is going to be x. If you want to move your graph to the left, 3 pi over 2, you are going to add 3 pi over 2. And then you have a vertical shift of 3, so we will say plus 3. To find your b value, take 2 pi over b, set that equal to your period, which is 6 pi. Switch those out. You get 2 pi over 6 pi is equal to b. Pi's cancel. 2 to 6 becomes 1/3, so 1/3 is equal to b, which becomes our b value that goes right here. This is really the process. There are a few more problems here. Actually, one more. Let's run through this quick. I know my video's gotten 20 minutes already, which is longer than I wanted. This one is sine. So this is set up like a sine function. We know it's going to have a negative a value since it's trending downwards. It looks like our amplitude here is going to be 1/2. So when we start writing, we'll have a negative 1/2. We do not need to do a phase shift here because of the fact our graph is starting kind of where we needed it to. It looks like our period is 2 pi over 5 again. So 2 pi over 5. And I think that meant our b value was equal to 5 in the last problem where we saw this graph. Yep, b value ended up being equal to 5. So you can go back a few slides to see how you solved that. As a reminder, this one did not have a phase shift, so we're going to say none. It did not have a vertical shift, so we're going to say none. So to wrap this up, we have our negative 1/2. It's negative because our sine graph started by going downwards. This is a sine graph, so I'm going to have sine. Our b value was 5, x plus 0, since there was no phase shift, plus 0 to wrap this up. Your homework assignment today is going to be worksheet 4.7. It might be called 4.8. It's whatever one is in Schoology for you, but you are going to work on doing this yourself. Thank you guys so much for watching. If you have any questions, make sure you're reaching out. Thank you. Have a great day.